Hello and welcome again. In our last lesson, you constructed your own cladogram using sequences of the COX-1 gene, which is found in the mitochondria. And you constructed that cladogram for the fruit fly, Drosophila, the gorilla, Pan troglodytes, the chimpanzee, and Homo neanderthalensis, an extinct hominid species. Today, we return to look at how to read a cladogram. And here we have a generalized diagram to represent a cladogram. And I want you to recall that a clade is a group of organisms that have evolved from a common ancestor. And cladograms are tree-like diagrams, like this one, to show the most likely sequence to arrange all of these organisms that we have and connect them to their ancestors. So if you have a cladogram that includes group H and group I, and some member of group H is actually more related to group C than it is to group I, then your cladogram does not reflect the true evolutionary history of the organisms represented. Because if something belongs in H, then it should be very much more related to the things in I than it would be to the things related in C and D and E. And like we pointed out previously, the Linnaean system of classification, which is based on morphology or form and some other evidence that came before the days of gene sequencing and molecular cladistics, most of those diagrams to show how things are laid out actually turned out to be correct. But there are some exceptions, and this tree of life has to be rearranged a little bit. Before we go into that activity, I want us to review how to read a cladogram. So, most recent common ancestor of F and H. Here we have F, and here we have H. H has got an ancestor 8. F has got an ancestor 5. G has got an ancestor 7, which is also an ancestor of H. But F and H have a common ancestor here with number 5. So it's pretty much logical to say then that 5 is the common ancestor of F and H. Next, we should look at which organisms evolved the longest time ago. Well, going back to some ancient ancestor here labeled number 1, that gave rise to two groups, 2 and 3. And group 2 gave rise to A and B. And these organisms evolved, and they are still being represented here today. So therefore, they evolved the longest time ago. The most recently evolved would be the ones that would have had to go through several generations or ancestors, like ancestor 3, then giving rise to 4 and 5, ancestor 5 giving rise to ancestor 7, and then to ancestor 8, which ultimately gives rise to H and to I. Of course, there's no number above here because this ancestral species 7 automatically gave rise to G, and this ancestral species 5 automatically gave rise to F. The most recently evolved would be the one that would have had to have the most ancestral organisms leading up to it. That's the most recently evolved. And that's how you read a cladogram. These points here are referred to as nodes. So I've put that word there so if you see it coming up in any document, you would know that that is called a node. Now I would like you to try these few questions from IB past exams. So go in and have a look and type the answers to these questions in your personal Google Hangout. So we've been looking at cladograms and molecular cladistics, and the IB Biology Guide points out that one group, the figwood family, which was classified by Linnaeus as an entire group that belong to one family? Well, today we realize from molecular cladistics that the figwood family doesn't actually belong as a family, because there's some members in there that actually are more related to other groups that are not included in the figwood family. And of course we can prove that by carrying out the same procedure that we carried out last time for the 4 organisms that we worked with. But instead of using the figwood family as our example, we are going to look at the crocodiles. And if you watched this lecture that I mentioned from the Yale professor, where he talks about the crocodiles being more related to the birds, then you would realize that this is another group that's not properly classified, at least in the way that it was classified historically. The reptiles, as including crocodiles, lizards, turtles, and the birds as being a separate group. Today, with evidence from gene sequencing, we realize that the crocodiles are actually more related to the birds. But we're not going to just accept it like that. We're going to take this example and search for evidence to verify it. So what you'll have to do is to go back to this video. You can get it here on the card above. Get instructions on how to use the NCBI website to get gene sequences for the COX-1 gene, to run comparisons among these 4, running it as pairs, and you can lay out a table like how I showed you. When you get the matches between the gene sequences of the COX-1 gene, then you can use that to lay out a possible cladogram for these 4 organisms. And in so doing, you can get evidence on your own to verify the claim that is being made by the professor. Because this is the true nature of science. Not to accept facts, but to be able to acquire the evidence to verify the facts. And not only can you go to the NCBI website, but if you wanted to take things a step further, the technology does exist to get samples from these 4 organisms and to get the gene sequences on your own. But these sequences have already been determined and they are stored on the database of the NCBI. So you are going to go in there and follow the procedure that we followed last time to lay out your table first of all, and then your cladogram. But there's going to be a small adjustment in the method that we used last time, because these organisms are much more distant in their relations as compared to a gorilla, a chimpanzee, and Neanderthal. So therefore we'll need to make a small adjustment, and I'm going to show you how to do that right now. Once you make that adjustment, then you can go ahead and get your data, put together your results, prepare a document, and upload it on ManageBack before the end of our class today. So I just wanted to clarify one thing. You're going to set up a table that looks like this. Here you'll have your 4 organisms. Here you'll have the name of the 4 organisms also. And as you run the sequences of the COX-1 gene, comparing the sequences for each combination, you'll write the percentage match in here. Then using that data, I want you to lay out your cladogram looking like this for the 4 species that we have in question. Please note that we have removed the iguana from the list and we've replaced it with the mountain grass lizard. And I also want to point out that the NCBI website does accept these common names as given, but when you put in the common name, it would also give you the binomial name with the genus and the species. When you're done, you can try running the same thing, but replacing the mountain grass lizard with the iguana, and then perhaps you'll see why I decided to remove it from this activity. But that would lead us into another discussion for another time.